Welcome to the brand new section of this course, Repeating Method Invocation using Recursive Algorithm. In this section, we will look at topics such as repeating the function invocation recursively, getting closer to tail recursion, and getting acquainted with functional, procedural, and backtracking recursion. Now let's move on to the video, repeating the function invocation recursively. In this video, we will take a look at performing the iteration procedure to repeat the process, then performing the recursion procedure to repeat the process, and finally recurring the immutable function. Let's start with performing the iteration procedure to repeat the process. The calculation of a factorial will be better if it's designed using the recursion approach. However, it's possible as well to design it with the iteration approach. Here we have a factorial iteration do-while.cpp code that we can use to calculate the factorial. Let's understand the code. We have a function named factorial that passes a single parameter that will calculate the factorial value we pass in the argument. You can see the function name factorial, and here we have passed the parameter to the function, n variable of type int. We depend on the value of n, which we pass to the factorial function in determining how many iterations will occur. As highlighted, we are running iteration using do-while loop. Every time the iteration performs, the result variable will be multiplied by the counter I. At the end, the result variable will hold the last result by combining the iteration's result value. In this block of code, we invoke the factorial function 9 times. Now let's compile and execute our code. So first go to our terminal, compile the code using the command g++7, followed by factorial iteration do-while.cpp std equal to c++17. After the successful compilation, type in /a.out to execute the code. Cool, we obtained the output as expected. Here, we have obtained the factorial from 1 to 9. Another technique in an iteration is using another iteration procedure. We can refactor this code to use the for loop in the factorial function. So for that, go to our atom editor, open the factorial iteration for directory, and in that, open the respective .cpp file. We have tweaked some changes in the previous code and modified it here. As we can see, we replaced the do-while loop for the for loop. However, the behavior of the program will be exactly the same, since it will also multiply the current result with the I counter each time the iteration performs. At the end of this iteration, we will obtain the final result from this multiplication process. So let's compile and execute this code. Go to our terminal and navigate to the factorial iteration for directory. Clear the screen by using the reset command. Next, compile the code using the command g++7, followed by factorial iteration for.cpp std equal to c++17. After the successful compilation, type in /a.out to execute the code. Nice! You can see we have obtained the output. Also, we have obtained the factorial from 1 to 9. Now that we have successfully performed iteration to gain the factorial purpose, either use the do-while or for loop. Next, we will see the recursion procedure to repeat the process. We saw earlier that recursion gives better performance in functional programming. We also developed the factorial function in the iteration approach. Now let's refactor our previous code into Factorial Recursion.cpp, which will use the recursion approach rather than the iteration one. So open the atom editor, then go to the Factorial Recursion directory, and in that, open the respective .cpp file. I have highlighted the entire code for you. Now let's understand this code in detail. Here you can see we have modified the recursion function to call itself at the end of the function. The factorial function calls itself until n is 0. Each time the function calls itself, it decrements the n parameter. The function will return 1 soon after the passed parameter is 0. So let's compile and execute this code. Go to our terminal and navigate to the Factorial Recursion directory. Clear the screen using the reset command. Next, compile the code using the command g++7, followed by Factorial Recursion.cpp std equal to c++17. After the successful compilation, type in /a.out to execute the code. Great! You can see we have obtained a similar output compared to our 2 previous code blocks. So we obtained the factorial from 1 to 9 using the recursion approach. After that, we will look at recurring the immutable function. Let's suppose we have the Fibonacci function that is immutable. We then need to refactor it to be a recursive function. So go to the Atom editor, open the directory Fibonacci iteration, and in that, respective.cpp file. Here is the code example of it. This code implements the Fibonacci function in the iteration way. The Fibonacci function is immutable since it will return the same value each time it gets the exact same n input. In this for loop, we generate the Fibonacci sequence. In this block of code, we invoke the Fibonacci function 10 times. So it's time to compile and execute this code. Go to our terminal and navigate to the Fibonacci iteration directory. Clear the screen using the reset command. Next, compile the code using the command g++7, followed by Fibonacci iteration.cpp std equal to c++17. After the successful compilation, type in /a.out to execute the code. Nice! You can see we have obtained the Fibonacci sequence using the iteration method. If we need to refactor it to be a recursive function, we need to go to our Atom editor, open the Fibonacci recursion directory, and in that, Fibonacci recursion.cpp file. This code will solve the purpose. Let's understand our code. As we can see, we have used the recursion approach since it calls the function itself at the end of the function. Here we call the function at the end of the function itself as it follows the recursion approach. After this brief explanation, let's compile and execute this code. Go to our terminal and navigate to the Fibonacci recursion directory. Clear the screen using the reset command. Next, compile the code using the command g++7, followed by Fibonacci recursion.cpp std equal to c++17. After the successful compilation, type in /a.out to execute the code. Nice! We obtained the same output as the previous one, but this time using the recursion approach. So here we have come to the end of this video.